Key benefits of cogeneration include high efficiency. We're able to extract a lot more of the energy out of the fuel than you can otherwise receive from the grid by itself. By putting the power plant at the same location as the energy is going to be consumed, you reduce the losses in heat, in transmission losses that would otherwise occur from buying grid electricity. So a high efficiency system means that you're going to end up paying less for the usable energy that comes out of it.
I think that another benefit is also CO2 saving, because if you compare the grid in the United States and the CO2 production as an average, I think 1 year ago the average for electrical production was roughly 1,300 pounds per megawatt hour of CO2 it's create. And if you install the CHP unit, which means that we will produce the electricity and the heat, offsetting of the fuel which will be burned and use it in the boiler, actually can set really low the CHP unit. As I mentioned, 1,300 pounds of CO2 it's create per megawatt hour, and utilization 1.5 megawatt of CHP unit, you produce only 650 pounds of CO2 per megawatt hour. It means that the CHP unit is still more green than the current grid.
The other benefit of CHP is the fact that it's immediately dispatchable. Unlike some of the other renewable technologies, wind or solar, which require the atmospheric conditions to be just right in order to produce the maximum amount of power. With a CHP plant, you can hit the button start and the engine will start and you will immediately have the power production. So that provides a high degree of resiliency. It is more reliable than technologies that rely on the transmission grid. Transmission typically being underground and also typically being highly reliable. As long as gas is present, power can be generated